let's graph a square root function with transformations. So just to remind you, the form that our transformations take is a x minus h plus k. And in this particular case, this problem that we're doing right here, we really have a, instead of parentheses, it's a square root sign of x minus h plus k. And specifically, we have -2 square root of x plus 1 minus 3. So to start out, I'm going to just write over here on the side that my a is equal to -2. My h is equal to -1. Now I know it says +1 over here, but remember, our template is minus h. So if I want to get +1, that would be minus 1. That's why -1 is my h. And then my k, that just keeps the same sign. My k is equal to 3. And I'm also going to remind you that h stands for horizontal. So those will be my left and right shifts in the transformation. My k stands for vertical, which I write with a k so we can kind of make the connection there. And those will be up and down transformations. And the other thing that I want to remind you is that the a and the k are outside of my function. So they are affecting y values. And my h is inside the function. The h will be affecting x values. So that's kind of a brief summary of what we're going to be doing here. So I am going to start this problem, and you should start all your problems with your parent function. So the parent function in this case is the square root of x. And I'm going to plot that. So I just made an xy axis. And I know that to get the square root of x, if I made a little t-chart here, here's my x, this is my y, that's a y, not an x. Then if I had 0, 1, 2, and 3, my square root of x, well, that's going to be 0, and that's going to be 1. But wait a minute, the square root of 2 is too difficult to find. I don't know what the square root of 2 is, and I don't really even know what the square root of 3 is. But I can go up to 4, and then I know that this is going to be 2. And I would actually go to my next perfect square, which is going to be 9, and this is going to be 3. So I know I can plot the function square root of x at the points 0, 0, 1, 1, so 0, 0, 1, 1, 4, 2, so 1, 2, 3, 4, 2, and then 9, 3. So that's 4, 5, 6, 7, 8, 9, 3. And I know that it looks kind of like this, and I'm going to just draw it in right there. So this is my function square root of x. Well, I need to layer these on in a particular fashion, and you want to start with your a first. So I'll make it green. So the a, my next step here, is going to be -2 times the square root of x. I'm leaving out my h and k so far. I just want to have my a involved here. So remember, the a only affects y values. So I'm going to take my y values, which are right here, and I'm going to multiply them by -2. So I have x is 0. If I take 0 and I multiply it by -2, I still end up with 0. Where x is 1, the square root of 1 is 1. Well, multiply that by -2, and that becomes -2. At 4, my square root of x is 2. Multiply that by -2, and I get -4. At 9, the y value was 3. Multiply that by -2, and I get -6. So I'm going to plot those points. So I have 0, 0. Right there is 0, 0. I have 1, -2. I have 4, -4. And I have 9, -6. -3, -6. So my graph has both stretched out and flipped over the x-axis. I took every y value on these points right here and multiplied it by -2, so it flipped it over and then doubled it. So now I've got the second part of my transformation. I've done my A. And what I'm going to do now is I like to do, let's make that green so we can see that that's the A. I like to do the H and K together. So if I'm going to do H and K, it means I'm going to move the entire green function, not the purple one. The purple one was our parent function. We've already made our first transformation now into the green one. I'm going to move the green one. Every point that I've plotted there, I'm going to move it to the left by 1 and down by 3. That should be a -3. I don't know where the negative sign went, but that should be a -3. So left 1, down 3. So let's take that. And I'm going to take this point right here, my very first point. I'm going to move it to the left 1 and then down 3. So this is now going to be the beginning of my graph. I'll take this point, move it to the left 1 and down 3. That's another point in my transformation. This point here to the left 1, down 3. And this point here to the left 1, down 3. So my final graph with H and K is going to look like this. I'm going to connect the points. I'm sorry, it's a little bit sloppy. Okay, the blue one is the graph of -2 times the square root of x plus 1 minus 3. That is my final graph. Good idea to label some of these points. This point right here is the point -1. Come on, make it look like a -1. -1, -3. This point right here is the point 0, comma, well, that would be -5. This point right here is the point 3, -7. Let's make that look proper too. Sometimes it's a little bit hard to write on these things. 3, -7. And then this point right here is going to be the point 8, comma, that was C6, -9. So I've labeled some of the points. Now, I need to determine the domain and the range of this function. Well, to find domain, I know that if I have a radical sign, that the radicand, that is what is under the radical sign, has to be greater than or equal to 0. So I can take my radicand, x plus 1, and set that greater than or equal to 0. So subtract 1 from both sides. I get x greater than or equal to -1, which I would write in interval notation, bracket -1, comma, infinity. And if I look at my graph, I'm looking at the blue graph right here, that seems to work quite well, because here my lowest x value is -1, and the graph just continues going on and on to infinity. So that is my domain. For the range, I really need to look at the graph. So I want to, and it's a little bit confusing because we're used to reading left to right, and here I might have to be reading down to up. I want the lowest y value of my blue graph. Well, I can see that this is going to keep going forever, and it's going to keep kind of going forever to the right, which we got in the domain, but it's also going to keep going down forever and ever and ever. So my lowest y value is -infinity. And then if I go from -infinity kind of coming up the graph, I can see that it stops right there at -3. And -3 is included in the graph. So that is the range. So the domain is that, and my range is that.